Flutterby, butterfly, on velvety wings in the warm summer sky.
And you are, of course, most welcome. Today we're looking at Project Euler through the lens of ChatGPT. I'm sure you know what this is by now. This is the chatbot that seems to be able to do everything. One of the things it's doing right now is scaring the shit out of every programmer in the world by the looks of it, because it can write programs faster than humans can. And it can do all kinds of other things as well. Let's say compose a tweet in the style of Peter Hitchens, and it will compose a tweet in the style of Peter Hitchens. There we are. You can ask it to compose a poem about custard. Write a sonnet about custard. There you are. And it will generate a nice little custardy sonnet. There we are. There we are. Okay, so can it solve Project Euler problems? Now, as you know, a big focus of this channel is Project Euler. I like to give little tutorials and little hints on how to solve all the problems. This chatbot could make my channel obsolete. Bearing in mind I only have 6 subscribers, so it's pretty much obsolete already, but let's imagine some kind of alternate universe where my channel is actually really popular and successful. Is this going to render my channel completely obsolete? Let's see. Okay, let's go to archives. Problem number 1, we'll start there. Very famous problem. I am going to give away the answer here, but you know, it's been solved like a million times, so it really doesn't matter now. Here's the problem. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6 and 9. The sum of these multiples is 23. Find the sum of all the multiples of 3 or 5 below 1000. Now, this is actually pretty easy to solve. You just total equals 0 for I in range. Might as well start at 3, go up to 1000, and then if I mod 3 is 0 or I mod 5 is 0, then total plus equals I, and then right at the end print total. Run that and you get the answer pretty quickly. So let's see if ChatGPT knows this. I want to put please because I want to be polite. Here it goes. So there's the code. It's pretty much, yeah, exactly the same as mine. There we go. I think that is actually exactly the same as the code I just wrote, isn't it? Oh yeah, I start at 3. I think ChatGPT is starting at 1 for some reason. Anyway, there is a better way to solve this. There is, of course, the clever method using arithmetic series. So for those who don't know, I did actually do this. I did a video about this, which you can go and watch. And I explained that there's a thing called an arithmetic series. So if we've got a series like 3 plus 6 plus 9 plus 12 all the way up to 999, we know what the first value is, we know what the last value is, we know how many terms are in the sequence, and we know the difference between the terms, it's 3. Therefore, there's a neat little formula, which I've completely forgotten, which you can plug in some values and it'll give you an answer. So it'll give you the sum of all the numbers below 1000 that divide by 3. We can do this for the 5s as well. So we do the 3s, 3, 6, 3 plus 6 plus 9 plus 12 plus 15, and so on up to 999. And we can do it for the 5s as well. 5 plus 10 plus 15 plus 20 plus all the way up to 995. Now you'll have noticed a problem here. We're counting the 15s twice, so we need to remove one instance of each one, so 15, 30, 45, and we do this, I think this is called inclusion exclusion. So we've included too many 15s, now we're going to exclude them. So we're going to find the arithmetic series for the 15s, 15 plus 30 plus 45, all the way up to 990, and then we're going to subtract. So we find this arithmetic series and this series, the 3s and the 5s, we add them together, and then we subtract the 15s. That's inclusion exclusion. Let's see if ChatGPT knows this. Can you solve Project Euler problem 1 without brute force? Do you know what? I'm going to do something else. Is there a quicker way? Because apparently ChatGPT knows, it follows the conversation, so it will know what I'm talking about. Here we are. Using a mathematical formula, arithmetic series. Yep, that's spooky, that's exactly how I typed it out. Okay. Hang on, what? 333 is not... 333 is the largest integer less than 1000 that is divisible by 3. Is it? I thought that was 999. Ah yes, so it's subtracting the multiples of 15. What? 66 is the largest integer less than 1000. Hang on. 66 is the largest integer less than 1000 that is divisible by both 3 and 5. What? It's gone wrong. So literally the first problem. I'm going to try and do that again. Can you solve Project Euler problem 1 without brute force? So it hasn't even given an answer there, which is weird. Yeah, so that's pretty much how you do it. See if it can do it this time. Yeah, this is correct now. Okay, so this is all good. Yeah, so now it's got the right answer using the correct method. So it did eventually get there, but I had to kick its ass a little bit. So that's not great. Okay, problem number 3. Largest prime factor. So this is just a prime factorization problem. The prime factors of 1, 3, 1, 9, 5 are 5, 7, 13 and 29. What is the largest prime factor of the number 600 billion, whatever that is? So here we use a method called prime factorization, as I said, and it kind of works like this. So let's say we want to find the highest prime factor of 114. So we have a variable called n, and we'll give it the initial value 114, and we're gonna divide out all the primes, starting with the smallest prime, which of course is 2. So divide 114 by 2 to give 57. 57 does not divide by 2, so we increment to the next prime number, which is 3. 57 divides by 3 to make 19. And then we increment p, and you probably know that 19 is prime, so this will increment up, and up, and up, and up until p hits 19. When n and p are equal, we know we found the correct answer. So the smallest prime factor of 114 is 19. So n equals, did I copy that? I did not copy that. Here's how the code will work. N is that, P is 2. Now, while n is not equal to P, if n mod P is equal to 0, then n divide by P. Else, now we want to increment P in a very specific way, so we don't want to go through all the even numbers. Once we've divided by 2, n will not divide by any other even number. So what we do is, if P is 2, increment P by 1. In all other cases, increment P by 2. So we go 2, 3, 5, 7, 9, 11. And I think that's all we do. And then print. And since n and p are going to be the same, you can print either one. I'm going to print p. I don't think it makes a difference, and that's the correct answer. And just to show you, you can print n as well. Again, makes no difference. Right, let's see what ChatGPT thinks of this. Can you solve Project Euler problem 3? So here it's just read the text from the page itself, and now it's gonna, oh, so it's slightly different to mine. The code's a bit more complicated. What's it doing here? Largest prime factor. Well, okay, this is completely unnecessary code. What is all this? This is a mess. Oh, it's got an is prime function. Why is it doing that? I suppose... Oh, so it's... No, this is wrong. It's doing... Okay, so what it's doing is... It's cycling through the numbers 2, 3, 5, 7, 9, 11. When it gets to 3, 5, 7, 9, etc., it's checking to see if it's prime, and if it is, then it's... I see. Yeah, so it's looking for primes. This is complete bollocks. Yeah, this is going to be very slow, checking for primes every time. That is a complete waste of time. Okay, so still not very good. Okay, let's try a harder problem. Number 14, collat sequence. It's the longest collat sequence. The following iterative sequence is defined for the set of positive integers. Using the rule above and starting with 13, we generate the following sequence. So we're starting at 13, the target is 1, and we proceed with the following sequence. So if the number is odd, we multiply by 3 and add 1. If it's even, we divide by 2. So 13 goes to 39 plus 1, which is 40, which goes to 20, 10, 5, 16, 8, 4, 2, 1. So it can be seen that this sequence starting at 13 and finishing 1 contains 10 terms. Though it has not been proved yet, the collat problem, it is thought that all starting numbers finish at 1. Which starting number under 1 million produces the longest chain? I'm not going to write out the full code for this one. I am just going to talk briefly about the brute force solution and a thing called memoization, which speeds this up massively. So In the brute force solution, I will copy the example from here. Not sure if the arrows will copy, but let's see. Oh yes. Okay. So in the brute force solution, we would check, let's take 20. So we would check 20 to see how long the chain is, and we would see that it has 1, 2, 3, 4, 5, 6, 7. So 20 has 7 terms. Later on, we'll come to 40 and we'll do the check over again. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9? 1, 2, 3, 4, 5, 6, 7, 8. That's correct, 8. Now we're going to completely disregard the fact that we've already found the chain from 20 down, and that's a complete waste of time because we're doing all these calculations again. In memoization, we're actually going to store these values in a dictionary. So 1 will have a chain of 0, 2 will have a chain of 1, 4 will have a chain of 2. This is all stored in a dictionary. When we come to 8, we will divide by 2 because it's even. That will take us down to 4, and then we look in our dictionary to find that, oh, we already have the length of the chain for 4, it's 2. So the length of the chain for 8 is the number of lengths is the length of the current chain plus the length of the chain we found, which is going to be 3. When we come to 20, we're going to generate a chain of 1, 2, 3, 4, 5, 8. I've already counted that. 8. And when we come to 40, we're going to divide by 2 to get 20. Then we're going to look in our dictionary and find that 20 has a chain of 8. So the chain of 40 is this one term here plus the 8, which is 9. I've got this completely bollocks, haven't I? 1, 2, 2, 3, 4, 5, 6, 7. It should be 7 and 8. God fucking damn. There we go. So 20 has 7, 40 has 8. Obviously when we come to 80, we know that's going to have 9 because it's just a chain to 40 plus the 8. When we come to 160, and so on and so forth. 320 will have 11. I think you get the idea. I'm just wasting time now, aren't I? There we go. So that is problem number 14. So brute force solution just goes through every number and calculates the collapse sequence, and the clever solution uses memoization. Can you solve Project Euler problem 14? Okay, again it's reading it straight off the page. Okay, so it is just doing the brute force solution, but it's generating the code. This time the code looks pretty good. And it's explaining in very good English what it's doing. There we go. But this is the brute force solution. So again, let's see you solve this using a quicker method. Brute force solution I described in the previous answer is already quite efficient and runs quickly for large values of n. Not sure I'd agree with that. If n was something like a billion, I think it would take a long time. We can keep track of the length of the collapse sequence for each starting number we have encountered so far. Yep. So we can use this information to avoid recomputing the sentence. Yep, that's fine. Yep. So that's pretty much it. Wow, okay. So, those are relatively simple problems. So let's try something a bit more challenging. I am going to cover my eyes. I'm going to mash the number pad 3 times and see what we get. Okay, so this is a problem I have selected at random. I have oh my god, blimey. I've no idea how to solve this. I've never encountered it before. Oh lord, looks like a bit of a bitch, this one. Okay, let's see what we've got. Right, I'm not going to go there, I want to go here. So, can you solve Project Euler problem 524? It is 524, yes it is. Right, here we go. Okay. Oh, hang on, what? Nope, it's the wrong problem. It's reading out the wrong thing. Hang on. This is not problem 524. Okay, so right, I'm going to stop generating there because that's not the problem I asked it to solve. So this is the one I asked it to solve. I'll copy the text in and see what happens. No, hang on. Right, let's do that again. It's done this as 12,212. It should be 12 to the power of 12. There we go. Let's try that again. Oh, it's doing it. Blimey. I haven't read the problem properly, so I don't even know if this is correct. So okay, is this okay? What I'm going to do then is copy this code into my IDE and just run it and see what happens. This is to do. By the way, this is way beyond my mathematical understanding. I should read the problem, shouldn't I? Consider the following algorithm for sorting a list. Starting from the beginning of the list, check each pair of adjacent elements in turn. If the elements are out of order, move the smallest element of the pair at the beginning of the list. Restart the process from step 1. If pairs are in order, stop. For example, the list 4132 is sorted as follows. Okay, let FL be the number of times step 2A is executed. Yeah, this is way beyond my understanding. I wouldn't get this in a million years. But this seems to have done it. So let's copy the code. Shamelessly copy the code and see if it works. Now this is probably a brute force solution, so it'll probably take ages to run. In fact, you know what? I think this is a bad example. I'm going to run a problem that I actually know. Here we are. Sum of digits sequence. Problem 551. I have been trying to solve this since before you were born. Let me just. Is that running? It's that. It's not going to finish, is it? Anyway, let A0, A1, A2 be an integer sequence defined by a0 equals 1, and each subsequent term is the sum of the digits of all preceding terms. So this 23 here is 1 plus 1 plus 2 plus 4 plus 8 plus 1 plus 6, and this 28 is all that plus 2 plus 3. It's essentially, really, it's 23 plus 2 plus 3, isn't it? This 38 is 28 plus 2 plus 8, and this 49 is 38 plus the 11 here. So we are given a 10 to the 6th, the 1,000,000th term in the sequence, is 31,054,319, and our question is find a 10 to the 15th, so find the 10 to the 15th term in the sequence. Pretty easy. In terms of the brute force method, it's pretty easy. So we want a digit sum method, which takes the value n, and all we're going to do is take the preceding term, add the digits of the term together, add that to the I'll show you how it works. While n is bigger than 0, oh, we need a total as well, don't we? Total equals 0. While n is bigger than 0, total plus equals, we're going to take the last digit of n, so n mod 10, and then we divide n by 10 to lop off that last digit. So n divide equals 10, and then return total for I in range, and we'll do this up to the example, 0 up to 10 to the 6th. What I should do is answer equals 1, answer plus equals digit sum, answer plus equals digit sum, answer. That should be correct, and then print answer. So this should take us up to the 1,000,000th term. I hope it does anyway. Oh, very close. I think I was just one away. So what do I do? Do plus 1. Okay, so I'm almost there. What have I done wrong? 319. Oh, I'm too far the other way, so it's minus 1. There we are, that's the 1,000,000th term. Okay, so let's find the 10 to the 15th term. Now the problem is, and I'm sure you've spotted this already, this is going to take a much longer time. In fact, I calculated this. I'm not very good at calculating, but it looks like on my system it's going to take 33 years to produce an answer. So clearly the brute force solution will not work. Normally I would try to solve this problem myself, but I'm so bloody desperate to get it done, I'm actually going to ask ChatGPT for help. So can you solve Project Euler problem 551? Hopefully it gets it right this time. No, hang on. This is incorrect. The wrong problem again. So yeah, not very good at the old attention to detail, ChatGPT. I'm not sure what's going on there. Right, let's copy the problem in, change that to 10 to the power of 6, and that to 10 to the power of 15. Oh, we can use dynamic programming. Oh, interesting. We can store the sum of the digits of the previous terms in an array and use it to compute the next term. However, we need to find a pattern in the sequence for it to be valid up to a very high number. Observing the first few terms of the sequence, we notice that it grows exponentially with a rate of about 1.3. Let's call this rate phi. We can use this observation to compute the value of the sequence at a high index by first computing the value of the sequence at a nearby index, and then using the rate to estimate the value of the desired index. Let's say we want to compute the value of the sequence at index I. We can start by computing the value of the sequence at nearby index, such as j equals I minus 100. We can then use the following formula to estimate the value of the sequence at the index I. We can repeat this process using the new estimate to compute the next estimate until we reach the desired index. Wow! Here's the Python code to implement this problem. Now I know that answer is wrong. I've actually, sorry to admit this, there is a list somewhere of all the Project Euler answers. And I have actually seen the answer to this problem. It begins with 7. That's all I'm going to give you, but this is completely wrong. So yeah, that's not the right answer. Oh, no, okay. First, notice that the sequence is eventually periodic since the sum of the digits of a number is at most 81 times its number of digits. The sum of the digits of a number is at most 81 times. Is that correct? Thus, there exists some positive integer k such that that's true. Adding these equations together, we get this. Simplifying, we get this. Yeah, this is way above my pay grade. Oh, it stopped. Why is it stopped? Okay, I don't think ChatGPT is really that good. Let's try something a bit further down. Let's try where can we go? 66 is an interesting one. This is another one I've been trying to solve for ages. I actually solved this years ago and I completely forgot how I did it. Diophantine equation. Consider quadratic Diophantine I don't know. Equations of the form x squared minus dy squared equals 1. For example, when d equals 13, the minimal solution is that. It can be assumed that there are no solutions in positive integers when d is square. By finding minimal solutions for x in d, we obtain the following. Hence, by considering minimal solutions in x for d less than 7, the largest x is obtained when d equals 5. Find the value of d less than or equal to 1000 in minimal solutions of x for which the largest value of x is obtained. Now, you can't do this in brute force solution because some of these solutions are massive. So I can't even remember the code I used to try and solve this. So let's see what ChatGPT can do. Can you solve Project Euler problem 66? Yep. For example, when okay, yeah. So again, copying the text off the page. We can use the algorithm for solving Pell's equation. This is indeed Pell's equation, which is a specific type of quadratic Diophantine equation. For a given d, we can find the minimal solution for the corresponding Pell's equation using continued fractions. Bollocks, I knew it had something to do with continued fractions. Then we can generate a sequence of solutions xy by iterating a certain matrix transformation. We keep track of the largest x value obtained and the corresponding d, and return the d with the largest x value. Here is the Python code to solve the problem. The output of the code is, I believe that is the correct answer. And okay, let's copy the code, see if it runs. So it looks as though ChatGPT is slightly better than I am at solving the easier problems, and about as useless as I am at solving the harder ones. Let's try this code, see what happens. There appears to be an error. Oh yes, you see. What's happened is I copied way too much. Okay, let's do that. Let's try again. Oh, it is running the code. Is it running the code? It is now. Okay, let's see how fast it's going. Print D. Stop and run. 2. Okay, so it's stuck in a loop at 2. So this code is not going to work. So I think it's probably stuck in the while loop up here. Let's see if that's correct. Yep, it's stuck in a loop up here. So this code is incorrect. Okay, so it looks as though my channel is saved. I don't think ChatGPT currently has the capability to match a really proficient programmer. So, okay, well that concludes my little assessment of ChatGPT. So, it's okay, it can do the really basic problems and show you some nice, efficient solutions. Anything beyond that, it's basically Bob useless. So, thank you very much for watching, and I'll see you next time, whenever that is.
Flutter by, butterfly, on velvety wings in the warm summer sky. Flutter by, butterfly, on velvety wings in the warm summer sky.